Hi guys, welcome to this session. Today I want to see how we can jump to tutorial sheet 2 because we already dealt with the first questions under biochemistry. So we want to see how we can look at the components of carbohydrates, monosaccharides, disaccharides, and different parts of carbohydrates. So I'll start with the first question that is saying, draw the structure of the alpha D galactophranosyl 1,6, alpha D glucophranosyl 1,2, which is a beta there, and then we have the fructofranoside, and we write this name using the three-letter abbreviation of the monosaccharides of this trisaccharide. And then the second part is saying, with an explanation, state whether this trisaccharide is a reducing sugar or not. So I'll start first of all by drawing the entire structure. I'll make it very easy, simple, straight, and simple and very straightforward. So yeah, let's get forward to the question. So remember that when you look at the question here, it's talking about three type of monosaccharides, the basic monosaccharides that are here. And the basic monosaccharides that I'm talking about here are the galactose. Okay, so just make sure the size of my handwriting is large enough for it to be able to see. So we have galactose here, and then the second structure that we have here is what? The glucose, and then the other structure that we have here is what? The fructose. How did I know to say we're talking about these three structures or these three monosaccharides? Because when you get back to the question, the first part of the question that they want you to draw is a galactopranosyl. So you know to say from the word gal, you are getting the word galactose, and the monosaccharide there is galactose. From the glucopranosyl, you know that the first part of it is the prefix part of it is the glucose. So you know that the second monosaccharide you're going to get there is a glucose. Then the fructose, you know to say the third monosaccharide you're going to get that from, going to get from that structure is what? Is the fructose. So we want to draw these structures and see how we can combine and come up with one structure from there. So how do they work and how we're supposed to work it out? So it's very easy and straightforward. I'll put up the structures of the individual parts. Okay, so I'll first start with the structure of galactose. So the structure is very easy. So I'll do that. We'll first put up that structure there. We have the oxygen right there. And then up the oxygen, we have the CH2OH. And then down there, we have right there. And then let me first of all draw the six-membered ring. So we have it right there. And then we have this part here connecting. And then the first part that you need to understand from here is that we are having the galactose, and the description of the lactose is an alpha. So we must be very careful about the positioning of the hydroxides, the position of the hydrogen, and everything like that. So what are they saying here? They are saying that this one here is an alpha galactose. So the alpha galactose they are depicting to say we must be very certain about where we put the hydroxide. So the hydroxide here is going to come here down there. So I'll use red so that I show you to say this is an alpha carbon or H. And I think something I should point out here is that when you're having the oxygen that is right there, and then down the oxygen, the first carbon that we're counting from there is called the numeric carbon, because you start counting from the numeric carbon. So I'll put up, in fact, I'll say our first carbon is here, second carbon is, this is a 2 here, this is a 3, this is a 4, this is a 5, and that is a 6. So our entire structure now continues. And then down here, we have what it takes there. Then we have there also. And then down there, we have the hydroxide, which is up. Why am I putting hydroxide up there? It's because we know to say galactose is an epimer. So we have that. That's the first structure that we're having. So what have we put up here? Under the structure of galactose, they're saying it is an alpha monosaccharide. So in an alpha monosaccharide, the positioning of the hydroxide is down right there. And then the rest of the structure comes through. If you want, you can put the hydroxide and everything. So I will indicate anyway. Here we have an hydroxide or H. And then here we have H there. And then here we have an hydroxide OH. And then down there we have OH. And then up there we have OH. And then the rest of the structure continues. So I've put up the first structure, which is called the galactose. It is an alpha galactose. Let's move on to the second structure, which is glucose. It's a six-membered ring. So we have that. we have that there, and then we have that there, that there, that there, and then that continues. So you note to say from this position we're having that, from that position we're having that. What is the state of this glucose? The state of this glucose is what? Let's check there. This is an alpha glucose as well. So you know to say the positioning of the numeric carbon on position 1, there the hydroxide must come down, because by showing the hydroxide coming down, it actually depicts to say that is an alpha one. So down there we are having, in fact let me use red so that you're able to say this is an alpha glucose. So OH there. And a numeric carbon comes immediately after the oxygen right there. So this is 1 here, this is 2, this is 3, this is 4, then this is 5, and then you know that we're connecting to the rest of the structure, which is CH2OH. So that's how it works out. So you have your structure of glucose. If you want, you can put up the rest of the structures. You have your hydrogen there, you have your hydroxide right there, and then you have your hydrogen there, then you have your hydroxide right there, and then down here you have your OH. So we have the structure of glucose, we have it right there. And then let's move on to the last structure there, which is fructose. Then one thing I should point out here is that I mentioned the word epimer. I was trying to point out to say the galactose as well as the glucose, these are epimers. How are they epimers? Look at position 4 on both structures. Position 4 on both structures is right here. Just here. That's position 4. Let me use red for me to give that description. So at that point, that is position 4. And here we have position 4. So you can tell to say at position 4, we have the hydroxide in that direction, like it's coming down. And then on the galactose, we have the hydroxide, which is coming up. So the state of the positioning of the hydroxide on the glucose and the galactose are different. One is going up, the other one is going down. It actually tells you to say the galactose and the glucose are epimers. So that is how it works out. So we have our first structure of galactose and we have our second structure of what? Of glucose. Let's move on to the last structure, which is fructose. So fructose is drawn a bit different from the two structures, because for it, from the first word itself, fructose, we're coming from the word 5. So it's a 5-membered ring structure. So I'll connect it like that. Therefore we go there, and then we have it right there. And then you note to say, since this is a 5-membered ring, and I was telling you to say the way we give a description of the numeric carbon is when you look at this other oxygen that is here. And then down there we have the numeric carbon. You start counting from 1, then 2 here, 3 there, 4 there, 5 there, and then you have 6 right there. So but for this one here, which is the fructose, you know that we have the oxygen there, so it's okay. You can either start counting from there, or you can start counting from the second one. So if you want, you can start counting from there. So for me here, I'll start counting from here. If you want, you can start counting from the other one. So this is 1, and then this is not going to be my second position, because you know that this one is attached to what? The CH2OH, and the other structure there is the hydroxide. So if this is 1 here, there's a carbon here, which will make it 2. Then this is 3. Then this is 4. Then this is 5. And then 6 there, we have another structure connected, which is CH2OH. And then down there, you have the hydroxide, which is what? Which is OH. So I want to make it very fast, simple, and straightforward. So the first thing I've done here is just drawing the individual structures of the galactose, the glucose, and the fructose. We have it right there. So now let's get back to the question. What are they saying? We want to come up with one structure, because they're saying that we are drawing the structure of the alpha D galactopranosio, which is 1,6. So we're saying there's a bond here, which is 1 to 6. And when we get back to the structure, because we numbered these ones here, the first position here at 1 is this one there, On galactose, our position 1 is here. Let me use a different color. On galactose, position 1 is right there. And you note to say galactose is more acidic as compared to glucose. So you expect that hydroxide for it to form the reaction between the two. And that reaction is called a condensation reaction because they're getting rid of water from the reaction, forming a glycosidic bond. So I think that's something to point out here. That the reaction that is going to take place here is the bond that is going to form there is a glycosidic bond, because the reaction is condensation. You're going to get rid of water. Between what carbon? Between carbon 1 and carbon 6. The 6 of the glucose. That's what we're having there. So there's a bond here. So what we're doing is I'm getting white so that you're able to see. I'm getting the hydrogen from the galactose because it is more acidic, and I'm getting the hydroxide from the what? From the glucose, forming what we're calling water. We're going to form H2O. And this type of a reaction is called a condensation reaction. It is a condensation reaction. And the bond that is going to form there is a glycosidic bond, because what you have here is the oxygen connecting to the glucose. Equally, what is going to happen here is a condensation reaction. And then, yeah, you go on straight and finish up with the reactions. So therefore, our structure here remains very easy and straightforward. We're just going to point out exactly what we have here. The structure of galactose is easy. So what we're going to have here is that structure here. The oxygen that there is connecting there. We have there, you have there. If you want, you can show it or not. And then at this position right there, I'm going to put it a bit down so that you can see what I'm doing here. So the bond that is connecting here is that bond there. You have the oxygen which is remaining right there. Connected to the what? It is connected now to the carbon 6. And on the carbon 6 we got the hydroxide. So we only have the CH2 right there. That is the only thing that is remaining. So there's a bond to CH2. Then down CH2 we have the rest of the structure. There we go. There we go. The structure of glucose. So therefore you have it. Then the rest of the bonds, if you want, you can show the oxygens or not. And then also, you know, to say there's a condensation reaction that is happening between glucose as well as fructose, and they're supposed to show that. Between what positions? You get back to the question. Between position 1 and 2. And position 1 here, after doing the numeric carbon, position 1 is right there. This is position 1. And position 2 on the other one is this one here. Position 1 has got the hydroxide. And which one is more acidic between the fructose and the glucose? It is the fructose. So from the fructose, that's why we're going to get the oxygen. We're going to get the hydroxide, sorry for that. So you're getting the hydroxide, which is bonding with the oxygen here, forming what we're calling water, which is H2O. In what reaction? A condensation reaction. So therefore, we continue. So this is just going to give the oxygen right there. And then what's the rest of my structure? The rest of my structure is I have another bond which is connected to CH2 because the hydroxide is long gone, and then the CH2 has got a different bond as well which is connected to the rest of the structure. So this, should I put it down or up? Anyway, you can put it up. So therefore you have it, then you have it there, you have it there, you have it there, then you have it there. So there's a better way you can write up this structure, but this is what the question is asking you to do. But one of the most important points I want you to take from this lesson is that you are trying to form a condensation reaction between the two bonds, which is the galactose, the glucose, as well as the fructose in the formation of water, forming a glycosidic bond. So this bond here is a glycosidic bond. The other bond here is a glycosidic bond. If you want, you can show the rest of the structures. It's okay. But this is what the question is asking you to do. And this is a structure that the question is asking you to draw. So guys, this is how you work it out. You've drawn your structure. So this is your structure right there. Drawn. We're done. The second part of the question is asking us to say, let me take you back so that you see what we're talking about. The second part of the question is asking us, with an explanation, state whether this trisaccharide is a reducing sugar or not. I'll ask you the question, what are reducing sugars and what are the components of reducing sugars? I'll point out to say, let's say important note. Okay? When you talk about the reducing sugars, you need to have free aldehydes, and ketones. Then you know to say that that structure is a reducing sugar. So now, in our structure here, do we have free aldehydes and ketones around the numeric carbon? And when you're trying to check for these free aldehydes and ketones, check for them at the positioning of the numeric carbon. And when you come here, the first numeric carbon that we had was in the first structure, which is galactose. I was at position 1. Here, this is position 1. And then there, it is right there, or it is also right here. But we started counting from here. So I'm getting rid of the other one. So this is off. So the numeric carbon is there, and numeric carbon is there, and numeric carbon is there. But on the numeric carbon, do we have any free aldehydes and ketones? We don't have them. So because of the absence of those free moving aldehydes and ketones in our structure, this structure there is a non-reducing sugar. Because the aldehydes that are here and the ketones are only participating in a condensation reaction in the formation of a glycosidic bond. So we don't have any free aldehydes and ketones in our structure here. So therefore, this structure here is a non-reducing sugar. A non-reducing sugar structure, because why? It has no free aldehydes and ketones in the structure. The ones that are numeric carbon are being used in the process of condensation to form a glycosidic bond. So guys, this is how you're supposed to work out the question. I look forward to being with you in the next session where we'll be looking at question 2. Thank you so much and have a great day.